Hey everyone, so this is going to be question number 8. Will Python do orders of growth? And we kind of rushed through this during discussion, so I just wanted to, if you're ever confused, I just wanted to clarify it here. But yeah, so remember that there are like 5 different types of runtimes. So there's like constant time. Let me draw like the graphs. Constant kind of look like this. If like no matter how big n is, like the amount of like operations is still like constant, it stays the same. That's what constant is. Logarithmic, here, let me draw it on a graph altogether. So logarithmic kind of looks like this. And it's like as n like grows really big, you have to increase n by even more. So this y-axis was like the number of operations, and this like x-axis was like the size of n, or like what n is. It might be like the length of a list or something like that. But yeah, and so in this case, logarithmic is that as you increase n in more and more, you have to increase it by even more to have like a similar increase in like the number of operations. And so on the other hand, we have linear, and that's kind of like when for like some increase in like the size or like n, you're gonna have like the same increase in like the number of operations by like a certain like factor. And then in the case of quadratic, I don't really know how to describe it, to be honest, but it like goes even. Oh, what the hell? It broke off. No. This is so sad. It's back. All right, awesome. Yeah, quadratic kind of grows like this right here. Oh wait, is that quadratic? Yeah, that's quadratic. But exponential grows even faster. It's like 2 to the n or something like that. And it's like grows like super fast, and it grows boop, 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 straight to the top. But yeah, and so that was like a brief overview of everything. But let's get started. And so we have this function called is prime. And what it does here is that it goes from the values like 2 to the n. And once it finds a value that's divisible by, so if n is divisible by I, then we know that it can't be a prime number, because the definition of a prime is that it's not divisible by any number from like 2 to n minus 1. And so we're going to return false right there. And once we go through everything, we're going to return true, because we know that it's prime because it wasn't divisible by any of these. Now it's saying, what is the worst case order of growth when in terms of n, of is prime in terms of n? And so the worst case means like at most how many, like what's the runtime of it? Like in the worst case, like if you pass in like a certain number, it's going to take like the longest possible amount of time for like around, yeah. I don't know if that made sense, but yeah. So in the case of is prime, the worst case situation is if we go through all of these values and make that check. And so we're going to check 2, we're going to see that it's not prime, we're going to check 3, we're going to see it's not prime. And we're going to keep on going all the way down to the n when you have like check n minus 1, and it wasn't divisible. And so because that, the worst case is when we pass in like a prime number and it makes all of these checks. It checks every single number, and if you notice, this is like a linear amount of like checks in a sense. So 2 through n is like around n operations, like n loops, and then we're going to make this check. So if n mod I is equal to 0, these arithmetic operations are going to take constant time. And so you imagine that we have a linear amount of iterations times like a constant like runtime inside of it. And so like n times 1 would be like O of n in a sense. And so we're making like we're going through n numbers, checking if they're prime. And so because of this, the worst case is when we go through all these values from 2 to n minus 1, check if it's prime. And so this is going to be linear time. So linear. And on the other hand, little aside, with the worst case, there's also like a best case scenario, right? And so think about like what the best case could be. Like what could be the shortest runtime? And so the shortest runtime isn't really like necessarily when you pass in like n equals 1 or something and it like runs super fast. Remember that in the case of like asymptotics and like orders of growth, we care about really large values of n. So we can't just say like n equals 1, that's going to be like a really short amount of time. It's going to be like constant. But the thing about this is that the best case is actually constant. And the reason behind this is that like if I pass in like, so remember that we're talking about like n as in like really big numbers. And so if we pass in like n equals like, I don't know like how many zeros this is, doesn't matter how many zeros there are. But one thing to note is that for I in range of 2 to n, 2 through n, and when we hit I equals 2, we're going to check, is this number divisible by 2? And we notice that it is divisible by 2. It's even. And so we're going to stop right there, and we're going to immediately return false. And so notice how we only actually went through one loop of is prime in the case when n was even. And because of that, it's going to be a constant runtime in the best case. So the best case is when n is even, and we only have to make like that one check. On the other hand, the worst case is when n is prime, and we have to like check every single number like 2 through n minus 1, and because that's going to be like linear time. So best case, constant, that's when n is even. And then worst case is linear, so when n is prime and we have to like go through every number to check. And yeah, so best, constant, worst, linear. Yeah, and so in this case, this is the next part. So what's the order of growth bar in terms of n? And so what happens here is that we have a function called bar. That's what we really care about. We have this counter I, and we have this value sum. And like notice how like, okay, so this like, you can simplify this problem a little bit. Notice how like sum, we don't actually do anything with sum aside from like adding to it. And we can consider that constant. And at the very end, we return sum. So you can pretty much think of this as just like I equals 1. And like you're calling like biz of n like a bunch of times. So that might make things a bit simpler. And in the case of the biz function, it does like pretty similar things. Instead of calling like biz in the case of earlier, what it does is that it adds up I to the power of 3, which is a constant operation. And yeah. And so let's first take care of like the subparts, right? Let's think about biz. And so what biz does right here is that it takes in the value n and it goes through the loop n times, right? And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I is 1, all the way down to n. That's going to be the loop n times. And what happens inside of here is that we have just like a bunch of like constant arithmetic operations. So I to the power of 3, that's constant time, etc. And so we have like a loop that executes like n times, a linear amount of times, and our inner loop executes is like a constant runtime. So that's going to be like a constant time loop, constant time, what's it called? I mean a linear time loop right here, runtime loop. And so biz of n is going to be linear based on n. And then in the case of here, it's pretty much doing the same thing. So it's going from 1 through n, I equals 1, going through n. And we're calling biz of n here. So you might be inclined to say that this is linear, just because of the fact that, you know, it's pretty much the exact same thing. But remember that you also want to consider the runtime of like the like individual function calls or like individual operations. And so in this case, biz is not a constant time operation, it's a linear time operation. Remember that it went through 1 through n, so it's linear. And so the outer loop is like linear, right? So we do it n times, and the inner loop has like a linear runtime, so it's like O of n. And so like n times n together is going to be like n squared. And so the order of growth of bar is actually quadratic, unlike biz, which is linear, because of this nested function call, which is like a linear function call, linear time function call. So bar is going to be quadratic, and this isn't part of the question, but biz is going to be linear time. And yeah, and so last but not least, we have the function foo. And so here we pass in a list, and in terms of like asymptotics, we usually talk about like the length of the list. So it feels like 1, 2, 3, 4, 5. N would be 5 in that case, like the list 1, 2, 3, 4, 5. In addition here, notice how you have like an index that you might have. But anyways, so what happens in foo is that we get the midpoint of the list. So the length of the list divided by 2. And if the midpoint is 0, return the list. And the thing to note about like if it's 0 is that, let's think about how that could happen. So either like list is of length 1 or 0, because 1 floor divided by 2 or like 0 floor divided by 2, that's going to be 0. So that's kind of like our base case right here. So if the length is 1 or 0, then we're going to stop right there. On the other hand, you don't really have to exactly worry about what the function does, but one thing to note here is that we split the list into like halves. So either we make a recursive call to list of mid beyond, or we make a recursive call to list of mid to the left. And so because of this, since we're splitting the list in half, what's going to happen is that, and also doesn't really matter what the -1 or the 1 is, to be honest. Just realize that either way, the list is going to be split in half. It doesn't matter what I is. And so what happens here is that like if the length of the list was originally n, and now with a recursive call it becomes n divided by 2, and you can imagine with another recursive call it's going to become n divided by 4, all the way down n divided by 8, all the way down to when it's like length 1 or 0. And this is the pattern that you're going to see quite often, where like the length of the list or something, or like n gets divided by like a factor, like in this case it was 2. And so in this case, there are also a constant amount of operations for each recursive call. So notice how we just like do like divided by 2, those are all constant time. So each recursive call does like constant amount of operations, and we have like a logarithmic amount of recursive calls, because like there's n divided by 2, n divided by 4, that's like log base 2 of n. And we're gonna have like around that many recursive calls. And so overall, this function is going to be logarithmic time. So logarithmic right here. And yeah, so, and it says write your answer in theta notation. And so what this would look like is the equivalent would be like theta of log n or something like that. And yeah, so that's going to be question number, 8. Will Python do orders of growth? And once again, let me know if you have any questions. Hope you have a great day.